So let us talk about mathematics module 1 of the 4th semester. So we'll straight away start with this chapter, and this is the one short video for the complete first module. Not one shot, maybe two shots, but still let us start. So basically in this chapter we'll be talking all about the preposition. So they will be having English statements. So sometimes it will be in the beginning you will be having only statements, and at the ending also you will be having only statements in English statements. Then you have to convert them into symbols and etc etc, but in the middle you will have only symbols instead of statements. They might give symbols and say to convert to statements, and if they might give statements and tell us to convert in symbols. So first, what is a proposition? So whatever I write in English is a proposition. So let me just say Bengaluru is in India. Okay, so this is a true, it's true. Okay, so proposition nothing but it is a statement in which a given context is either true or false. So this is a statement, right? English statement, it's either true or false. Okay, so each proposition can be true or it can be false. Okay, true means the value is 1, false means the value is 0. Okay, so this is the basic thing we should know about proposition. I don't think we need some English examples to explain it furthermore. So let me just start away. So proposition is denoted by P. Okay, it can be denoted by any number also, like letter other like P, Q, R, S. It can be denoted from A to Z, anything. It depends on the one who is asking the question. If the question paper is asked in the question paper, if the question is asked, they will give basically P, Q, R, S. They won't go except PQRS. Okay, so it will be always PQRS, and sometimes in worst cases, not worst cases, difficult scenarios, they will also ask T. So first we will be talking about logical connectives. Okay, so I wrote a statement. Okay, suppose I wrote some English statement here, and then I have another statement, another English statement. So in some way, the anything that connects both the things, right? This statement and that statement is known as logical connective. So sometimes I am happy and I am rich. So see here, I am rich and I am happy. So this means here this is one statement, this is one statement. I am adding both the statements through this one logical connective. I can also put right or I am rich or I am happy. So this is also one logical thing. If I am rich, then I am happy. So same statement, another logical connective. So logical connectives are many are there. So straight away, let me just write. So this is one symbol, this is one symbol. This symbol is for and, logical and. This symbol is for logical or. Then this symbol is if, then. Okay, this symbol is if and only if. So I will be talking the scenarios where it will be true and it will be false. So let us talk. So given a statement P. Okay, if P is true, if it is true, then the value of that will be 1. If P is so they will tell what is the negation of the statement. So negation is nothing but the symbol is like this. You can either write like this or like this. So both are same itself, same. So if P is 1 here, so the negation P will be false. So it is just the opposite of the actual value. Okay, it will be 0. Similarly, if P is 0, okay, then negation P equals to 1. So this is a basic thing about negation and other thing. So we also have conjunction. Okay, so one by one let us start. So we finish about negation. Okay, negation is done. So second one, I will write the symbol in bracket, this or this. Then now conjunction. Conjunction is nothing but and. Okay, so we will be talking about and. So let us take two statements here. So one proposition is P, another proposition is Q. So we know that the truth table we have to write for this. So 0 0 0 1 1 0 1 1, and now I need P and Q. it's nothing but a simple multiplication. So 0 into 0 is 0, 0 into 1 is also 0, 1 into 0 is 0, 1 into 1 is 1. So P and Q is nothing but it returns only if both the values are high, it returns this. So in other ways, let me just explain. Few people always get confused in this, like they won't understand the 0 and 1. So they'll write true. So okay, so it is basically false, 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 true, true, false, true, true. Only if both the statements are true, it is true. In rest of the cases, it's false. Okay. Now let us move on. Okay, so this is nothing but conjunction. So I don't have to erase everything. I'll just go to the next one, disjunction. So conjunction is over. Third one is disjunction. Okay, here also same values I'll take 0 0 0 1 1 0 1 1. So this is OR. If any one of the input is true or it is high, then the answer is true itself or high. So suppose in this case, if here both are 0, so it will be 0. If any one is 1 1, here it is 1 1, both are 1, then 1. Understood? It's same like the DTCO we had studied in third semester. Normal thing. If you need more basic explanation, just tell me. I'll make a separate video on that. Why? Because I don't think that basic things are required. But still, if still it's required, I'll separately make a video, such that if you watch that and then watch this, you can say understand this topic. You understood this, right? For and, both should be high, both should be 1, both should be true. Then only you will get the value true. If any but in OR, any one should be true. It's not necessary that both should be true. Any one should be high 1, then you will get 1. Okay. So let's move on to the next thing, that is implication. Okay, I won't change this. I'll just change the symbol. Okay, fourth one is implication, the arrow symbol. Okay, if P then Q. This is very interesting. This also have one easy trick to remember. So I'll just tell you. So this is 0 and this is 0. Okay, so whenever from here to here it is going, right? So 0 to 0 is true, 0 to 1 it is increasing, it is true, 1 to 1 it is same, 0 to 0 when the condition is same it is 1 1. If it is increased, it is 1. Only when it is decreasing from 1 to 0, then it is false. In simple words, from true to false, it is false. But in rest of the cases, this is always true. Understood, right? The value should not decrease. Here, from 1 to 0, it is going, right? So only in this place, it will be 0. 1 to 0. This thing is nothing but this 1 to 0. Only when it is decreasing, the answer is 0. In rest of all the cases, like see 0 to 0, it is 1, 0 to 1 it is increasing, it's 1, and 1 to 1 is the same, equal, right? It is 1. Only when it is decreasing from 1 to 0, from true to false, then only it is false, or else it's true itself. Okay. So now we have another symbol, that is nothing but biconditional. So bicondition is like this, if and only if. So this is same, okay, same as that this was a symbol, but only thing is it works from the both the sides like this. Understood? There are two ways to understand. So first thing, so see here 0 to 0 it is equal, right? Then it will be 1, answer is 1, we know that. And now again I have to do like this, 0 to 0, oh it is also 1, so it will come 1. Now when I go for 0 to 1, and then we have to do 1 to 0. So 0 to 1 is 1, but 1 to 0 is decreasing 0, so it's not satisfying. So this will be 0. Similarly, this will be 0 and this will be 1. So don't get confused. Basically, whenever you get this, both should be same. Either it should be 0 0 or it is both should be 1. Then only you will get true. If it is different values, then it is false. Okay, very simple. Okay, and that's it. So this was biconditional. Then we also have another thing like exclusive disjunction, which has a shape like this. I'll be telling what's that now. So first let me just make a table. So okay, so let me just speak about exclusive disjunction now itself. So it's same as this, what is that, biconditional, just the opposite of biconditional. So when I put that table now, you will understand. So P, Q, P and Q, P or Q, P implies Q, then P biconditional Q, and then we have exclusive disjunction, right? So we have all these things here. Let me just do everything. It's visible, yeah, it's properly visible. Okay, done. So 0 0 0 1 1 0 1 1. So AND thing. So for AND both should be true. So 0 0 it's 0, 0 into 1 again 0, 1 into 0 is 0, 1 ones are 1. Okay, or any one is high, then the answer will be high. It means if any one is true, you will have true. If any one is 1, then you will have 1. So both are 0, both are false, so it's 0. And it's 1, any one is 1. So here we have 1, 1, 1. Now don't be seeing this value, okay? You should not be seeing this wala. You have to keep seeing this one. Okay, okay, from now I'll be using this red marker also for highlighting the difference also. Now P implies Q. In P implies Q, what I said, it should not decrease itself. If it is increasing or if it is the same to same, then you will have 1. So equal 0 to 0 1, 0 to 1 increasing 1, 1 to 0 decreasing it's 0, then 1 to 1 it's 1. Biconditional means what? It should be same, right? Both the things should be side. It will go like this also, like this also, like this also. So if it is same, both are same only, it will be 1, or else it is 0. Okay, here both are 1, so 1, both are 0, 0. So exclusive disjunction is nothing but opposite of this. If both are same, it is 0. If both are different, it is 1. Okay, if it is same, then 0. If it is different, then you have 1. That's it. So this is the basic table which will help you throughout the module. Okay, so throughout the first module, this will help a lot. So through this, we will be having some extra what to say extension from this itself. Okay, so I'll just erase this. Now we have just seen the basic. Okay, for even the questions have not started yet. So now moving on to the first question or thing, like let me talk about tautology. So T autology. So tautology, and we have here a contradiction. Okay, so tautology means, so given a proposition, the context of the statement is always true. You know the definition of proposition. A proposition is a statement in which a given context is either true or false. It can either be true or it can either be false, right? So if it is always true, everything is true, all the values true, it's called as tautology. If it is always false or all the values are false, it's called as contradiction. Okay, so they'll ask about all these things now, and they might also give a problem and ask us to like what is this, just write the negation of this, write the symbol in English, clear English or good English or fluent English. So similarly, these kind of things can be asked from this type of topics. So every time it cannot always be tautology or contradiction. So we know that if it is every time it's true, it's tautology. If every time it is false, it's contradiction. If it is not both of them, then it known as contingency. So contingency is nothing but the normal situation where it can either be true or false. We will be having mixed values, right? So let us see a problem, a normal and simple problem. Okay. So they have said like a question which is related or concerned with a certain triangle. So we have a triangle A, B, C. So they have said that first proposition they have get triangle ABC is isosceles. Okay. Then they have also said another proposition Q saying that triangle ABC is equilateral. And then they have also said triangle, okay, even proposition R. Just a moment. Yeah, I was just confused with the spelling. And it is also equiangular. Okay, angular, and the U. So same triangle. It is isosceles also. It is what to say equilateral also, and it is equiangular also. So since it is equilateral, okay, so basically what is saying equilateral equiangular and it is isosceles. So anyhow it will automatically support that. So they have said that write down the proposition in words. Okay, so these are the given propositions. So they have asked P and negation Q. So we have to write this in words. Okay, so now how will we write this in word? So given a proposition P, first let me write triangle ABC is isosceles. Okay, and so let me just write and directly and. Okay, so negation Q means ulta, opposite of this. Triangle ABC is equilateral, so I will write it is not an equilateral and not an equilateral. Okay, I hope you understood this, right? So this thing is P and this thing is negation of Q. Okay, they have what they have asked here that I have written in English. So let us not stop with this. We have further 5 more same like different propositions to convert. So another let us take. I hope you are writing down, okay, because I am going through a lot. Like it's not that simple to explain this subject, because I have to speak a lot, write a lot, say a lot, think a lot, and most importantly explain properly. So negation P or Q, so it is or. Okay, so what is P? ABC is a isosceles triangle. So triangle ABC is not isosceles or. Okay, okay, let me just use different color for this or. Okay, this thing is negation of P. Okay, or and then use or an equilateral. So I don't have to write or ABC, triangle ABC is an equilateral. Simple English, right? You can directly write like this also, equilateral. So this thing is only Q. Okay, so if I am just erasing, just pause, go back and see it again. So now we have to find P implies Q. Don't get confusing from here itself. If you are getting confused from here, like how to do this, as soon as you saw this, then it's really very difficult for you to do the remaining things. So now let us see. First I'll write P. If P, then Q, right? This symbol is nothing but if. Okay, let me just write this P and this is Q. So if this P, then Q. So what I have to do, I just have to, so P is there, just write P as it is. Before P write if, after you finish P, then TH in, then you go with Q. Okay, I hope you are understanding. Let me just write. So if, okay, wait, let me do it like this. If triangle ABC is isosceles, then it is equilateral. Okay, you understood, right? So P and Q is same to same. Just before P if comes. So see here, this is P and this is Q. Very simple. Okay, so now let us move on for another question. So it says Q implies P. Did you get confused again? You shouldn't be. Okay, I hope you didn't. Simple. So let me just write it again. If triangle ABC is, I'll just write EQL. Okay, I don't want to write again and again. Then it is isosceles. Okay, I hope you understood this. So you will be thinking like why R is written here, but it's not like they are not asking anything written. So they have R's here now. See here, negation R implies negation Q. So how will you write? First R, what is R? Triangle ABC is equiangular. So if I take negation, then triangle ABC is not equiangular. Okay, triangle. Okay, since we have a bike like this implementation, so I have to use if triangle ABC is not I'll just write angular, then because of this symbol, then it is not equilateral. See here, this thing except for not is q. When we add not, it's negation q. Same thing, this this except for not, if you remove, it is nothing but r. If you add not, it is negation r. Since we have this implementation if then, but we have both negate r and negation q, so it will become false, it will become ulta. So since it was ABC is equilateral, then ABC is not equilateral, ABC is equiangular, then ABC is not equiangular, that it will become like that. Okay, so we have almost implied like used all the proper conditions, but one thing is remained, and that is nothing but biconditional. P if and only if negation q. Okay, so this is also very simple. So first we will write P. Okay, here don't start writing with if and all, here if and only if. Okay, so this will be written like first, if triangle ABC is isosceles, where did it go? Okay, triangle ABC is isosceles, then triangle ABC is not angular, and if okay, so see basically two things comes here. So when P imply so it's nothing but P implies Q and Q implies P, it's like that. So you can write in this way, if triangle ABC is isosceles, then it is not equilateral, comma, if triangle ABC is not equilateral, then it is isosceles. So this is a way to write that, but also you can write that triangle ABC, triangle ABC is isosceles. So if and only if triangle ABC is not equilateral. This is one of the way to write that. Else we can this is equals to this, right, this whole thing. So you can also write like that. Okay, if triangle ABC is isosceles, then it is not equilateral, comma, if triangle ABC is not, same thing you have to just write ulta, then triangle ABC isosceles. You understood, right? If triangle ABC is isosceles, then it is not equilateral. If it ABC is not equilateral, then triangle ABC is isosceles. This thing is triangle ABC is isosceles if and only if it is not equilateral. That's what I had written at the beginning. Okay, I hope this made you like how to say understand the concept. So we also have a another question, like they will be asked like construct the truth table for the following compound propositions. So they have given as a proposition like P or Q and this whole and R. Okay, so for this how we will be doing? So P, first I have to write P, then Q and then R. Okay, so since we are taking three variables, so we will be having a truth table like this 0 0 0 0 0 1, and so let me just go fast like this, 4 times, then 2 times 1, 2 times 0, 2 times 0, 2 times 1, 0 1 0 1 0 1 0 1. Okay, we got it. So see here I have two things here. First I have to do this, then I have to do the whole thing. So first I will write P or Q. So let me do it like this. Then once I find this becomes one thing, then I have to write P or Q and R. Okay, so first let me find P or Q. So if it is P or Q, I won't be thinking or caring about this thing. I'll only take these two things. Okay. So both are 0, so it is 0. Both are 0, again it is 0. Any one is 1, 1, 1, 1, 1, 1. Everything done. So now I have to multiply these two now. Why? Because it is P or Q and R, right? So now this and this. So since both first thing is 0, so it is 0. This is also 0. Since it is AND, wherever you have 0, so here you can see only first two are 0, remaining all are 1. So basically you know, right, what is AND. If any one is 0, then it is 0. If both are 1 only, you will get 1. So since here is 0, 0 is also 0, 1, 1, 1, 0 is there, so it is 0. Both are 1, 1, 0 and 1. So that's it, you got your answer. Okay, let's not just stop at this, we'll find another thing. So P, R, Q and R. Okay, so I'll only rub this part. So first let me find Q and R. So I have to multiply these two. Both are 0, 0, 0. This will be 1, 0, 0, 0, 1. Why? Because only these two places it is 1, 1. Remaining all are like 0 is having. There is 0. So now here P, R, then Q and R. So this is one whole thing which we have found here. So this value or P. So both are 0 here. Okay, I am not taking this thing completely. Okay, so 0 and 0. See, 0, 0, 0. Both are 0 again. 0. Both are 0. Yeah, 0. Fourth one it is 1. Yeah, it is 1. Now here all are 1, right? So I'll just write 1, 1, 1, 1. Okay, so this is my truth table for this. I hope you understood, right? So I'll again explain you a little, taking another other example, all type of possibilities. Okay, so let me take an example like P and Q implies negation R. Okay, so that's interesting. We have negation R. So let me just first, to make it easy, write negation R. You can directly write, but it will lead to some complication, and you might just end up doing the sum wrong. Okay, so like negation R is ulta value of that. So it will be 1 0 1 0 1 0 1 0. Now first thing, so they have not given this in actual bracket. So I can assume one thing. So it can be P and Q, the whole implies to negation R, or I can take first Q implies to negation R, and then I can do it like and Q. Let us take P and Q as one thing. So first I will take P and Q. Okay, if I do P and Q, then see wherever 0 is there, it will be 0. So see here 0 0 0 0 0. So only last two is 1. So 6 times 0. So 2 times 1. So now we have Q. This thing implies, this whole thing implies to negation R. Sorry, negation R. So now see here 0 to 1. Okay, so it is P and Q whole implies to negation R. So 0 to 1 it is increasing, then 1. 0 to 0 it is equal, so 1. 0 to 1 again increasing, 1. 0 to 0 it is same, so sorry, 1. 0 to 1 increasing again, 1. 0 to 0 equal 1. 1 to 1 equal 1. 1 to 0 it is decreasing, bro, so it is 0. Understood? I don't think further things are required now. So okay, I am just done with this thing. So let us move on further to other concepts. So let me just take another example, normal example. So they have said let P and Q be primitive statements for which the condition P plus Q is false. Okay, they have said P and Q be a primitive statement for which, so they have said P implies Q is 0, false. Then determine the truth value of the following compound proposition. So they are saying that P and Q. So I have to find the truth values for this. What they have given, P is one proposition, this is one proposition, and P implies Q is 0. Okay, so now I have to find the value like for P and Q. Okay, I have to just what is it, determine the truth value. I should not make any table here, but I have to determine the truth value. Okay, so see here P implies Q is false. we know that P implies Q is false only when it is from 1 to 0, which means you can simply just write a truth table like P implies Q, right? So P Q 0 0 0 1 1 0 1 1, and just write the truth value, it is 1 1 0 1. So see here, in only this scenario it is false, so you can take this value. So where P is 1 and Q is 0, so what will be the value of P and Q? 1 and 0, it will give us 0, right? That's it. So this is how you prove it, that first one, it is P and Q is equals to 0. Okay, similarly first we proved found P and Q. Secondly, we have to find negation P or Q. So we got to know that P is 1 and Q is 0. So negation P, so negation P is 0 or 0, which is gives us 0. So another one, Q implies P, 0 implies 1, so this gives us 1, it is true. So the value is 1. Then negation Q implies negation P. So Q, it is 0, so negation Q is 1. Then P is 1, negation P is 0. So 1 implies 0 is again 0. Why? Because it's decreasing. Then that's it. Yeah, we only here they have asked only 4 questions. Okay, I hope you understood this, right? Similarly, they might give given like P is also 0, Q is also 0, and R is 1. So just find out the thing. Why am I seeing? Let me just write P equals to 0, Q equals to 0, R equals to 1. So now let us find P or Q or R. So 0 or 0 is 0. Then R 1, this thing is a 0. Why? How? 0 or 0 is 0. So this gives us 1, because 0 or 1 is 1. Okay. Let us see one more thing. P and Q and R. Just see here, since we have 0, all are multiplication. So obviously, if only 1 0 is the final whole answer will be 0. Here, since all were in R, any one is 1, then obviously we will get 1. Okay. This was easy one. Let us see another one. So this is P and Q, which implies R. So P and Q, 0 and 0 is 0. 0 implies R is 1. So this is 1. Why? Because it is increasing. So this value is 1. Similarly, P and R implies Q. Okay. R is what? 1, Q is 0. It is 0. Why? Because it is decreasing. So P is also 0. 0 and 0 gives us 0. Okay. Next we have P implies Q implies R. So since they have given bracket, first Q will imply to R. So Q implies R 0 to 1, it is 1. Then P is also, P is 0. So 0 to 1 again. So it is 1. So this is called truth value is 1. So we are done with this thing. I hope further things are not required. Suppose they give this thing, I hope you can do it by yourself, right? I mean, like, it's not that difficult. So let us see some problems on tautology and contradiction. So okay, let me also tell you, solve a problem. So sometimes they usually ask in examination is like they'll give a question, P or Q. Okay, this is one thing, and P implies Q. Okay, and Q implies R. Okay, and this whole thing implies R. They'll ask what is the truth value of this whole F thing, I mean whole thing. So you have to, what you have to do now, first see 3 variables are there, you have to like P, Q and R. So it will be like this, right? Let me just put that table. Okay, so 1 0 1 0 1 0 1 0 1. So first let me find P or Q, then I'll find P implies Q. then I will find Q implies R, okay, then I will find this thing, okay, then I will find this whole thing, then I will find the final question itself. Okay, let me just tell you. So these two are here. Since it will take a lot of space and I can, that thing won't, I cannot write, so just 1 0. So P or Q. So wherever it is 1, it is 1. If both are 0 only, it is 0. So both are 0, both are 0. I have 1 in Q. So all are 1 now. So P implies Q. 0 to 0 is 1, 1, 1, 1. Since here it is 0, whenever you see 0 on the left side, right, always put 1, because obviously 0 to 1 or 0 to 0 itself, it cannot be 0 to minus 1. So it is only 0 to 0, 0 to 1, so it will always be 1. Whereas coming to 1, whenever it is decreasing, 1 to 0, so 0, 0, 1 to 1, 1, 1. Q implies R. So see, like I said, 0, 0, both are 0. First starting is left is 0. Then 1 to 0 is 0, decreasing, 1 to 1, 1. Then 0, 0, so directly write 1, 1. Then again 1 to 0, then just 1. So now what I have to do? I have to multiply this and I have to multiply this. Is it confusing? I'll just erase this line. Okay. Okay. So now I have to multiply this and put here this and this value. Okay. If I do like this, it might be good. Okay. So and is there, make sure and is there, right? So 0 and 1, it is 0, wherever you see 0 just put 0, both are 1 only, then 1 1. So 0 0, then 1 1. Now what I will do, this value and this value, okay, so this both I have to multiply now. This whole thing we found here, right, which is being multiplied with this, so I have to multiply this again. So 0 0 and here it is 0, so 1 0 0 and this is also 0 and this is 1. Now I have to take this value implies to R value, okay, this value now will imply to R value, okay, 0 to 0, okay, so wherever is 0, first I will put 1 1 1 1 1 1, and only in this place I will see. So see here, okay, it is 1, 1 to 1 is 1, last place again 1, 1 to 1 is 1. So see here, since we got all of 1, this is a tautology. So they might ask you like, prove that this is a tautology. So this is how you prove it is a tautology. So it can be asked in two ways. One way it is like just find the truth value of this given what is that proposition, or they can say, right, prove that the given statement or the given proposition or given compound proposition, actually it is compound proposition, which is either which is tautology. So they will just say that it is tautology, or they might also that prove that it is not a tautology. So these are things like that. So I forgot to mention what is compound proposition. See, P is just a proposition, right? If there are more than one proposition, then it is a compound proposition. Okay, so if one or more propositions are logically connected or related to each other, connected using logical connectives, then it is a compound proposition. Okay, I hope you understood the way you do. If you want more problems on this contradiction or tautology, I'll just explain you. Okay. So moving ahead, we'll be talking about this laws of logic. Don't worry, it's nothing related to Newton over here, Isaac Newton, Sir Isaac Newton. So laws of logic, is already midnight here. So there are totally 10 laws of logic, and apart from 10 laws of logic, you have some remarks. Remarks nothing but some formula type hints, so which will be very helpful for us to solve the problems. So let me just start with this laws of logic. I might take a break now, so later when I explain this laws of logic, it might just sound different. So let us start with the first laws of logic. So first laws of logic is the law of double negation. Okay, so one by one, if you just write down in your book or paper, it will be good. So first law is nothing but a law of double negation. So you know this is negation. So double negation is double negation. So 2 times negation of anything is logically equivalent to the itself. I mean, so see here, p is there, okay. So if I take negation of p, so it will be like this. Now again, if I take negation of this negation p, it should be ulta of p, right? So it will become p again. So instead of writing these two things, what I will do like this directly. Negation of p is logically equal. Either I can put 3 lines or I can do like this, is equal to p. Okay, so this is nothing but our first law of logic, law of double negation. Second one is idempotent law. This basis law are like important for us to solve further problems. Why? Because we'll have to write from how did you do the changes. So you have to write like this since or in the bracket just from this law, from that law. So idempotent law is very simple. So p or p and p and then or of same prepositions. Okay. So p or p is again logically equivalent to p itself, and p is also logically equivalent to p. How we get this is just see here. So 0, if suppose p is 0, 0 or 0, you will get 0 itself, and if p is 0, 0 and 0 also you will get 0. Suppose it is both are 1 and 1, 1, 1 or 1, 1. Okay, so this is simple and very easy to understand. You have to make a truth table, and if they suppose they ask you to like this is a confirmed question, by the way. They might ask explain all the laws of logic. So you have to write the laws of logic and what the law is. First one was p or p, second one was p and p. Both are logically equivalent to p itself, but you have to make a truth table, p, q and p or p, p and what is that, p, okay, sorry, p and p, and you have to write 0 0 1 1. Okay, sorry, this is also this won't come. You are taking only p, right? Or else if you want you can again write like this 0 1 also. Both are fine. So third one is identity. So identity law. So from the name also you can remember. So here we had studied, right? So T naught represent tautology and F naught represent contradiction. Tautology means is always 1. Okay, this is always 1. F naught means it is always 0. So here we have P or F naught and P and T naught. Okay, so this is first one, this is second one. So remember here or is there and here and is there. So here what will happen, p let it be anything. So this is always 0 and this is always 1. So whatever the value of p is, suppose p is 0, we will get 0. If p is 1, we will get 1. So that's what identity law says. Okay, let me just write here. So f naught is always 0, and so I will take p as 0 and p as 1, p as 1, p as 0, or f naught is always 0. So 1 or 0 is 1, 0 or 0 is 0. So whatever the p value was, I got that. Okay, let me take in tautology. 0 and 1, p is 0 and p is 1, and t naught is always 1. So 0 into 1, 0, 1 into 1, 1. So whatever the p is, I am getting that itself. So you have to make a table like we did last time. You should write logically equivalent to p. So this is our identity law. Next one is inverse law. Okay, inverse is also kind of very simple. Here what we will be doing is p, or again we will take p itself, but we will take negation of p. Okay, so this is always equal to tautology. How? Let us assume, suppose p is 1, negation of p will be 0. So 1 or 0 is always 1. Suppose p is 0, or negation of 0 is 1. So I am always getting 1 itself, because since it is or, it will select the higher input. If any one is true, it will select true. So this is always t naught. This is 1. And second one, under inverse law, p and negation p is logically equivalent to f naught. How? It is and. Okay, so suppose no matter what, if you take any value, here it will be the opposite value. So in every case there will be a 0, right? So it will always be a 0 itself. Suppose P is 1 and P is 0. Okay, negation of 1 is 0, negation of 0 is 1. Since it is AND, it will always give us 0 itself. Okay, so that's what it says. This is inverse law. Then we have domination law. So in domination law we have so we had this identity law, right? In identity we had taken P or T naught. Okay, sorry, I mean P and T naught we had taken. So always apply with 1 whatever it is. Here it is just ulta of this identity law. Instead of and we are taking or. So P or T naught will always give me T naught itself. Why? Because it is or, right? So suppose P is 0 and P is 1, or and it is 1 1, T naught is 1. So I am always getting 1. So 1 is nothing but tautology. Since here it was 0, then it would, we could say that it's P itself, but here it is not logically written to P. Why? Because or we are taking or to T naught. T naught is always 1. So no matter what value we take, 1 is already there. So obviously 1 will come in the output. So that's why T naught will be displayed here. So P or T naught is always T naught. Similarly, P and F naught is always logically equivalent to F naught. Why? Because F naught is 0 and it is AND, right? Let it be 0 or 1. Always it will give 0 itself. So 0, if it is giving always 0, then it is logically equivalent to F naught. It is just ulta of identity law. Once I show you the paper thing, you will understand it more easily. Then sixth one is commutative law. So in this we have same thing. So P here now we will be starting. We will start the usage of another preposition. P or Q is logically equivalent to Q or P. Okay. So to prove this, we have to make a table also like this. P Q 0 1 0 0 0 1 1 0 1 1. Okay. Here I will take P or Q and here I will take Q or P. So 0 or 0 is 0. Here 1 is there, 1 is there, 1 1 1 1. Similarly Q or P, first it will be 0. Again I will have 1 1 1. How you got this? Simple, right? 1 or 0 is 1, 0 or 1 is 1, 1 or 1 is 1. Only 0 0 0. So both are same. So this is true. Okay. So another statement is P and Q, same thing. Here or was there, here now and will come, is logically equal to Q and P. The same way I did that, you will get 0 0 0 1 for this 0 0 0 1, and for this also you will get 0 0 0 1. Okay, why? Because your value has 0 0 0 1 1 0 1 1, right? If you AND this, if you multiply from here, so like it's like 2 ones are 2. So 1 into 2, 1 into 2 is also 2, and 2 into 1 is also 2. It's like that. Understood? So I hope you are understanding. Any doubt you have, you can just comment and or message me. I'll straight away make a video on that particular topic and upload, because it's not that difficult. It's very easy for me. Then seventh one, absorption law. Okay, so absorption law, it says P or, now in the bracket P and Q. So this is one thing, is logically equivalent to P. Okay. We have to like prove this, how it's like that. So let us take truth table. Okay, 0 0 0 1 1 0 1 1. So first what I have to take? P and Q. P and Q I have to take, right? So P and Q 0 0 0, this is 1. P and Q, correct, right? It's and. Now I'll take P or P and Q. So this and this I will do and. So 0 0 0 0 0 0 0 1 or 0 1 1 or 1 is 1. So see here, whatever the value of P was, we got the same for this. That's why it is logically equivalent to P. Just remember, here or should be there, here and should be there. Similarly, the same thing, here also P, here also P and Q, only the symbol will change. So here it was or, here you put and, here it was and, here you make it or. Again this is logically equivalent to P itself. If you want, we can try that. I'll just change this symbol here, okay? This symbol, this symbol, this symbol. Okay, let us try. First I have to find P or Q. 0 0 0, remaining all are 1. Now P and P or Q, this and this. So first two will be 0 itself. Why? Because 0 and 0, 0 and 0. Now here both are 1, here both are 1 into 1, 1 into 1. So again you got P, understood? So this is nothing but your absorption law. I'm just going a bit fast because this is a one shot video for that entire module. Any topic, if you want me to explain in detail, if you say, I'll just make. It's not like only this module, any module. Just message the name of the topic or comment, best it's comment. Then 8th one is De Morgan's law. De Morgan's law is negation of this whole thing, P or Q. Negation of P or Q. It's very simple, like it's multiplying minus for some number. But here the only difference is you will have negation P, negation Q, but the symbol will also change. Okay, it's like ulta of this number. So negation of this number also will make it ulta itself. So we had R, negation of R also will be like and type. Just remember like that. Okay. So negation of P and Q will same logically equal to negation P or negation Q. We are not just saying it like this itself. I'll show you. Okay. P Q, right. So let us take this whole table itself. 0 0 0 1 1 0 1 1. So first what I will do, I will take negation P also here and negation Q also here. 1 1 0 0 1 0 1 0. Okay, now I will take P and Q. If I prove this, then automatically this also like you have to just change ulta. So P and Q, 0 0 0 1. So negation of P and Q. Okay, negation of this. So it will be 1 1 1 0. Now what I will take, this or this, negation P or negation Q. 1 or 1 is 1, 1 or 0 is also 1, 0 or 1 is also 1, 0 into 0 0 0 0. So see here, I got this, right. See, this is this, this is this. From this table I got this, it is logically equivalent. Similarly, if you do like this also, it is logically equivalent to that. This is our De Morgan's law. Next we have associative law. In associative law, it's same like how to say absorption law, but here instead of P or P and Q, we will be having another variable as R. So see here, here everything should be R, P or Q or R. Okay, let it be any propositions. So once it is like this, so what we can do, right, is logically equivalent to, I will remove this bracket and put for this two, and I will keep R as separate. P or Q or R. So for few I am not using the truth table, for few I am using the truth table. So see here, this is very simple, like how I showed in the beginning, right. So P or we had to solve that problems in the beginning. We had this kind of problem itself over there. So they had given us the three position P, Q, R, the triangle ABC wala. So in that we had this kind of thing. It's same like that itself. Since it is R, no matter if any one is true, that whole thing also will become true. It's like that itself. Similarly, P and Q and R is logically equivalent to P and Q and R. This is helpful for us. Sometimes we have to group, right, some terms. So P alone we cannot expand sometimes. So if you have like this, if you take P and Q like that, suppose the subtype will be like negation P something, and here negation Q also is there. So we can make it as negation P and negation Q. Now this we can write as negation of P or Q. This was one of the law, right, De Morgan's law previously, like that. Understood? So this is our associative law. Associative law, just remember, grouping is associative law. Absorption law is nothing but it will become P itself, P or only P. It's not necessary that there should be it will be arranged in this order itself. These letters can shuffle also. Okay, don't get confused in that. And last one is distributive law. So distributive law is same thing. Here both will be different. So here both were R, right. If I just make one and, okay, P R, Q and R. Okay, so what will happen now? whatever is there inside the bracket will become like this. Okay, outside of P or Q and P or it's like a normal multiplication. So you have A, right? A into, if you do B plus C, so it is AB plus AC. Okay, but here we had A into B. So if you have to multiply P or this, so it will be P or A. So A plus B, if you like suppose in some way if you have to multiply, okay, that won't make it out because it is logical terms and that is just basic maths. You just understand from here. Or is there, right? So we will first pair this one and then we will pair this one, and should be there. Similarly, okay, let me just write it properly. P or Q and R is logically equivalent to P or Q and P or R. Similarly, P and Q or R is logically equivalent to, first here P and Q or P and R. How to remember this is also very simple. Whatever is inside, right, that will be in between two brackets, these two things terms. Okay, here inside and was there, here outside will be there. Here inside or was there, here outside will be there. Okay, which is outside this bracket will come inside, which is inside will come outside. So these were our 10 what to say, laws of logic. Yeah, actually I just showed you the logic here, law of here, but you have to actually prove this also. You have to take the truth table P Q R whole thing 0 0 0, that 8 things is there, right? Like the full whole value, right? You have to first find P or Q, P or R, Q and R, Q or R, and then P and Q, P and R, everything, all 6 things you have to find. Just let me just write. P or Q was there, P or R was there, P and Q was there, and P and R was there. Then inside the bracket we had Q or R and Q and R. You have to find all these things from these three. Then you have to find P or this one term with which we had in the question, Q and R. Then you have to find P and Q or R. Then you have to find this 2 into the 2 things, the whole expand we did, and then you have to write the whole truth table like that. Okay, I am not writing that because it's very simple. If you try to do it once, you will understand. So if you want to see here, it's there over here, like I have written here properly everything. Okay, so this should be easy and simple for you to like take screenshot, and for associative law how it is logically equivalent. Then here for all that domination, commutative, absorption, De Morgan, like I said, see absorption law both were say P or P and Q. Here only what to say, same it was, right? So absorption law is P or P and Q is logically equivalent to P itself. Instead of P and Q we had Q and R, so that will go for our distributive law. Similarly, if we have all the same things P or Q or R, it will be associative. If it is same one, both are two are same inside, like here it is commutative law. You can just understand and remember this, right? It's not like though it will take time to like by heart or remember all these laws, but you know how to do it. If you get scenarios, you understood, right, how you are getting the actual values. Now next there are some remarks over here, let me just write it. So we have negation P or Q, it is logically equivalent to negation P and negation Q. Actually this is this itself. Okay, don't get confused, this is our same De Morgan's law itself. Main thing I will tell, P implies Q is logically equivalent to negation P or Q. Now negation of this whole thing, P implies Q, it is logically equivalent to P and negation Q. Okay, so this negation should be equal to this negation if you take like that. So it's simple, I'll tell you. So see here is logically equal to this. How it is equal to this, I'll tell. P implies Q, they say it is logical to negation P or Q, right? if I take whole negation of this, we know from that De Morgan's law. So it will be like negation, double negation of P will, because already negation is there, R will become and negation Q. Since double negation is there, again it will become P itself, so it is P and negation Q. Suppose if you don't understand, just remember De Morgan's law and you can write like this, get the answer like this, okay. So you don't have to always learn also. Sometimes if you just know one or two laws, with the help of that law you can get this. Okay, then let us move on further to another topic, that is duality. So duality is also a very simple thing. Two types are there in that. One, directly they will just give a proper complete statement and say to find the duality of this. And sometimes they will give you what to say, some problem first you have to solve and then you have to get the duality. Okay, so duality is represented by P of D. So now P of D, duality of duality is again P itself, like how double negation was there, negation of a negation is P, like that duality of duality is also equal to P. So you don't have to worry that, just I will write the remarks here. P, duality of P is logical equivalent to duality of Q. Okay, this is the principle of duality. Negation P duality is logically equivalent to negation P. Okay, so P or negation P whole duality is logically equivalent to P and negation P. Okay, so these things just don't get confused. These are just remarks which might be useful for us in further cases. So now they have given a problem. Okay, so we have to just this was one of the problems I think which we have already solved. So let us still see. Okay, we have a problem here. They have said that let x be a specified number. So x is a specified number. Specified number. So they have given three propositions. So what they have asked is write down the negation of the following propositions. Okay. So if x is not a real number, then it is not a rational number and not an irrational number. So if x is not a real number, then it's not a rational number and not an irrational number. So we have not, and. So if then, okay. So not, then this is if, then here only and is there. So three different things. So I can write. So this is a you can either take this whole thing as P proposition, this thing, or you can take it as negation P because not is there. Okay. So I will take if it is negation P, then what will be only P. So P will be like x is a real number. Since not is there, then this is a negation of a statement. So P, x is a real number. Q, it is not an irrational number, right? So it is x is a rational number. Then R will be x is a irrational number. Okay, so now how it is formed? So it is in the form like, now if I write this is negation Q, P. If P, then Q. So negation P implies Q. Then with Q we have and negation R. So we can write as we have negation P, negation Q and negation R, and P is implies to this. So this can come in a bracket since it is and. Then we can write it as negation P implies negation Q and negation R. So what they have asked, this is the given statement. We have to find the negation of this statement. Okay, I will just erase this whole thing since we found the statement. So what was it? Negation P implies negation Q and negation R. So they have asked us to find the negation of this thing. So we saw in the laws of logic, negation of P implies Q is negation P and P and negation Q, right? P and negation Q. Okay, I'll just recheck it, I mean cross check it. Yeah, P and negation Q. Okay, so now first this whole thing is P and this whole thing is Q here now. So P will be as it is, negation P and negation Q. Okay, there will be a negation here. Why? Because negation Q, right? This whole thing is Q. So negation of Q means negation of this whole thing. Now negation of this whole inside thing. So we know that, right? Again I'll write negation of P and Q is logically equivalent to negation P or negation Q. Since we have inside also negation, so I will be having like double negation Q or double negation R, so which is nothing but Q or R. Negation P and Q or R. Okay, so I got this. So further can I simplify it anything? So I cannot. So you can also take that distributive law also and apply here, like negation P and Q. So negation P and Q or negation P and R. We don't want to increase so much. We have to simplify it, right? It should be in small thing. So P and negation Q found. So that's more than enough for us. Okay. Now I will just keep this book here. Okay, I hope you can see the question here. So the question is, Vimala will get a good education if she puts her study, okay, if she puts her studies before her interest in cheering. So if is here, okay, we don't have any then. So you have to understand that if this statement, then this statement. So let me just write. So I can rewrite this statement, right? If Vimala puts her studies before her interest in cheerleading, okay, CL, then Vimala will get a good education. Okay, so this is my P statement, this is my Q statement. Okay, so what they have said, express the each of the following statements in symbols, negate them and write in smooth English. So first we have to write the statement symbol. So what it is? P implies Q. You know what is P, right? P is if she puts her studies before her interest in cheerleading. What is Q? Vimala will get a good education. So P implies Q. I have to take negation of this. Okay, negation. Let me write it separately. This is a given thing in symbols. In symbol, I have to take negation of this. You know what is negation of P, which is logically equivalent to negation, P and negation Q. So P and negation Q. So I got the negation. Now I have to write this in smooth English. You know what was P, right? P is nothing but Vimala puts her studies before her interest in cheerleading. And negation Q. What is Q? Q is nothing but Vimala will get a good education. What is negation of that? Vimala will not get a good education, and so I can write she will not get a good education. It is smooth English. You can also write and Vimala will not get a good education, but that's not a proper English, right? And she will not get a good education. You know what was given? First we converted into symbol. We took the negation of that symbol and then we wrote it in smooth English. Okay. Similarly, we have another proposition. So Nirmala is doing her homework and Kamala is practicing her music lessons. So it is simple, P and Q. P is Nirmala is doing her homework and Q is Kamala is practicing her homework. What is the negation of this P and Q? It is logically equivalent. First we found the symbol in symbol, negation P or negation Q. So how to write this in smooth English? Nirmala is not doing her homework and Kamala is not practicing her music lesson. Okay, negate P is can negate, Q can negate, you will get. I have written down also so here. Okay, so Nirma, so second one, negation R or negation S. I just skipped it here. Why? Because who will write so much when you understand something? Okay, so here they have given a question. Let me just copy it. So they have said without using any truth value. So you should not use truth value. Earlier it was very easy to find the truth value of each word and then find. So what they are saying, prove that P implies Q, whole implies R. This term is biconditional or logically equivalent to negation P or Q, whole implies R. Okay. So now we have this thing as U and this thing as V. So basically, I didn't say you one thing about what is that transitive and substitution rule somewhere. So if U is logically equivalent to V, okay, and V is logically equivalent to W, then U is also logically equivalent to W. So if this U is logically equivalent to V, then U is equals to V and then V is also equals to U. It has to be, okay. So we have to first let us keep one place as it is. So here we have negation P or Q implies R as V. V is equals to this, U is equals to this. Okay. So now P implies Q is logically equivalent to. So we know that. Okay, we know that P implies Q is logically equivalent to negation P or Q. Okay. So in V, if we solve V, negation P or Q implies R. This can logically be written as, see here. So I'll just write P implies Q implies R. So now my V and my U is equal. That's it, done. Understood, right? So I will write again here, P implies Q implies R is logically equivalent to negation P or Q implies R. So this thing I can write as P implies Q implies R. How this became P implies Q? Because P implies Q is logically equivalent to negation P or Q. From the remarks we know that. Okay. So if you cannot mention from this law, and for if we are using law, we can simply write the name of the law. But here we don't know, right? So we'll write, since you write this thing and just prove it. So done. Okay, it was quite simple and understandable. Okay. So now we have another compound preposition. So they have just asked us to simplify. So we have to make it as small as possible. So simplify the following compound proposition using the laws of logic. So now here we will be using the law of logic. P and Q. The main problem in this module is that we won't be knowing which to use where. But one thing you can understand by the parts how they divide in the question paper. Further other laws also will come, other topics also will come. So this is not duality we are speaking here, it's just problems on laws of logic. Okay, P or Q and negation P and Q. Okay, so here we have negation P and Q, then whole negation of that thing, then P and Q and that thing. So if I take negation of this inside, so there are many ways you can do this. So first let me just take negation of this thing here. So negation of this thing is nothing but double negation of P and will become R, and negation Q. Since it is double negation, only negation will remain. So I have like this, P and Q. Okay, oh sorry, I just copied it wrong. It is P or Q, not P and Q. Okay, sorry. So here P or Q, and so this thing I simplified into this. Now see here, I have R inside, okay, and then I have and here outside. So this is similar to our De Morgan's law. So here what happened? Okay, here also we have applied one law. This law is nothing but De Morgan's law. Okay, uh, since De Morgan's, so just write De Morgan's law. What we have used, negation of P and Q is logically equivalent to negation P or negation Q. You have to I did this. Now here and is there, okay. So we know distributive law, P or Q and P or, this is this is not same, okay. This is same, P is same, but this thing is different, this thing is different. So it is in the form of P or Q and P or R. So we know that this can be written as P or Q and R, okay. We know that right, distributive law. So it will be written as P or Q and negation Q, okay. Instead of R we had this. So we know that from I think it was identity law, right? Let me just check here. So no, it is not identity law, it is inverse law. In inverse law we have a proposition into negation of its proposition is always 0. So this thing will become 0. Why? Because Q and negation Q can have any value 1 or 0. So negation into negation of that will always ulta itself. So this whole thing becomes 0. Only P will be left. So we solved it. So we just got P. You will be thinking like if there are further complicated sums, how you will do it. It's very simple. In that, how you do is nothing but there will be fixed set of questions for this. I presume some 8, max 8. So if you just practice those 8, 3 or 4 among them only will come, okay. So you don't have to worry about that. Few of that I'll just solve now itself again. So we have another proposition, P or Q and R, okay. This whole thing has a proposition R negation Q, and again we have to take the negation of this whole thing, okay. So now how will you do this, okay. So see here, this is one term, then this whole thing is another term. So first we will solve the innermost term. So we have negation, okay. We will try to take negation for this. So De Morgan's law, or else the simple thing, we have negation here and we have negation here, then whole negation is there. Let me simply take first outside negation, let me take. So if I have to take this negation, I will imply this negation. So negation of negation P or Q and R, or double negation of Q, sorry, this will become or, right. Since it was or, it will become and, okay. We took De Morgan's law, we applied, right. So this negation or will become and then again this negation. So double negation will just go off, double negation will just go off. So we are left with only Q, okay. Just see if you can always cancel out that negation or not, okay. So now we have P or Q and R, okay. So now if I just take out this bracket, so this is one term, this is one term, this is one term. Now since both 3 are also in and, I can apply associative law here, okay. You know that associative law, right. P and Q and R, if it is like this, it is like this only, right, one thing. So this can be written as P and Q and R like this, okay. So let me just write it like that, P or Q and R and Q, okay. Now I can rearrange this. So P and Q is logically equivalent to Q and P, am I right? Simple. This was one of the law, right. I think it's identity or something law. So here double negation thing happened. First we took De Morgan's law, De Morgan. Then we took double negation, and then here what we did, we applied associative law. Now here I think idempotent or identity law. Let me just check which law is that. Okay, it is commutative law. From commutative law, I can write it as Q and R. Okay, then I have P or Q. Now again, this is P or Q and Q and R. Now you will be like, what shall I do here? Like we cannot apply a distributive law, right? Since here and is there and here or is there. So now again you can do one thing. This is one term. Okay, this is one term and this is one term. You can write like that. So what we did here, we took and paid it here, right? I can send this Q again inside now. Okay, so this I can do it, right? P or Q and Q, this whole thing, and R. So here P or Q and Q is there. Okay, so this is same like association law, where P and P or Q is logically equivalent to P. The only difference is we have Q instead of P. So it is nothing but Q and R now. This thing will become like this. Okay. I know it's kind of confusing, but I'll just show it in the book. It's better I just start explaining like this itself. So first, double negation happened, De Morgan's law. So this negation, double negation will come inside. So both the negations got off. So we have double negation of this whole thing, double negation for this thing. Then for Q also negation was there here, right? Here negation was there, right? So negation of negation Q will be again give us Q. So this thing will be have no negation, no negation. Then associative law, what I did, I paired this with this, R and Q. Then I took commutative law and made it like this. Then again I used associative law and paired Q with this thing again. Again I paired it like this. Then we know here from absorption law, this will be logically equivalent to Q. I can again, to make it further simplified, I can also write it as, okay, let me just show here, and this is right. So it is, won't you write, just a minute. So I have here, I hope you can see P or Q and Q. So again I can apply commutative law here and make it as Q and P or Q. So now it is in the form of that actual thing. Again, if I use commutative law, Q and Q or P. So now you can properly apply associative law. Directly also you can do here. It doesn't make any difference. So again, this is logically equivalent to Q. So this whole thing reduced to Q because of associative law. If you see associative law here, you can see here P or Q or R is logically not this one. Sorry, I am saying associative from that time. Where did it go? Yeah, absorption law. Sorry, absorption law. Associative law is just to group it with different pair. In absorption law, see here P or P and Q is P, P and Q or Q is P. It's not necessary it has to be in that place. So here suppose Q and P is there also, it will logically into P. Same thing here it has happening. Okay, let us move to the next problem. I don't think whiteboard is required here. Okay, so now see here P implies Q implies R is logically into P and Q, which implies R. Okay, so now first what you are doing here, we are opening this. Q implies R is nothing but negation Q or R. So I have P implies negation Q or R. Now again this is in the form of, okay, let me just write whiteboard also. You have to understand, right? P implies Q implies R. Now I open this, so it will become negation Q or R. Again it is in the form of P implies Q. Now first I open this, now this whole thing. So P implies Q, negation P or Q, whole Q is nothing but this whole thing is Q, right? Okay, that's what I did here, negation P or negation Q or R. So now I will take from associative law, I will pair it P or I will make like this or R. So this thing can be written from De Morgan's law, negation P or Q, negation P or negation Q. So it can be written as negation of P and Q. You have to understand here, I have written here De Morgan's law. Then or R. So see here, P implies Q is logically equivalent to negation P or Q, right? Right. So now see here, negation P or Q. So I can write it as P and Q implies R. Okay, so that's what we wanted in the question. You understood? Laws I have written here. So I'll just tell which law has which and where. So this is you have to write since like that. For these two steps, you have to write this. Then from here, first we applied associative law. Associative to group it like this. Then I applied De Morgan. And then at the end, I just applied again from this thing. This comes here again and just proved it. Okay, I hope you understood it, right? It's taking a lot of time to explain this one simple module. Then again, I have another question. P negation P or negation Q is logically equivalent. So it implies P and Q and R. Okay, this should be logically equal to P and Q. Okay, let us start again. So I have negation P or negation Q, which implies P and Q and R. This whole thing should be logically equivalent to P and Q. So first I can take negation P or negation Q. It's negation of P and Q. Okay. Then again, now what I will do? So this thing implies P and Q and R. This whole thing is one term. Okay, whole thing is one term. Now it is in the form of P implies Q. So P implies Q, but I have to write P implies Q is logically into negation P or Q. So I have to take negation. This whole thing is P. This whole thing is Q. So negation of negation, double negation will come. Why? Because here already it has negation, right? Negation of this thing, double negation P or P and Q and R. So here this double negation will go off. So I have P and Q or again, if I can take pair it again like this, right? So we are solving this problem here. So we have P and Q or P and Q and R. So here from this thing I can just group it like this and leave it like this. Then again I have these two things. I know suddenly the clip changed. Why? Because the storage was not sufficient and the video automatically got paused. So we had left here. So here you see from associative law, from like this I grouped it to like this. Okay. Then now you see here this is and this is same. Okay, P or P and Q. Okay, so I can this thing can also still be like this also. So see here we know from this which law is that absorption law. Okay, from absorption law we had P or P and Q is logically equivalent to P. So we have P or P and Q. So this thing will be logically to P and Q. That's it. So we got here. So mostly what mistake we do here, we try to see for once we group this, we try to go for distributive law, like P and Q, P and Q and Q like that. No, but that won't happen. Okay, though we have distributive law over here. See here. We have or here and inside both inside we have and. So this we can write as P and Q, but don't do that. Why? Because you can also try that, but if you have to do that, instead of Q you can take R. Okay, that's different way. So if you take P and R, if you group that, so you can write as P and Q or R. Then P and Q or R is there, right? So Q or R and then you will be having again this and Q. So there you can again that's headache. No, why you want simple absorption law is there. So P or P and Q, then you will get this P, simple. So further we have another some questions over here. See here, this is one sum. So this is the question. just write the question, try to solve by your own. If you cannot, then see here. Yeah, anyhow I have shown, you can take one proper picture, this thing screenshot, and then you can get the notes of this in other portals also, or some model question for solutions also. This is another question. So I'll do here. Now we have to talk about duality. Okay, I actually explained a lot, but then later I realized that it's not recording because storage was insufficient. So I'm explaining it again. For you, it's the first time. So duality is nothing but, suppose we have a proposition which consists P and Q or R. Then again, instead of R, let me put tautology. So duality is nothing but we will be changing the symbol, opposite of the. So if it is and, it will become R. This will become and, T naught become F naught. Okay, I'll just take an example. So I have P and Q or negation P or Q and negation R or S, and then again I have R and S. So first what I have to just write U is equals to this. Now UD is equals to symbol same, it is and you make it R and R and R, P Q negation P Q negation R S. You understood, right? It should be like this. Let me take another example where a tautology is there. P or T naught and Q or F naught. So this can be written as P or is there, it will become and F naught, or Q or is there and T naught. Okay, very simple. They don't think it will be so simple. Now we will see the twist. They gave like this: P implies Q, whole implies R, and they have asked to find the duality of this. So duality we know only it's of our and, or, and tautology. So this will become this or this, tautology will become this or this. F naught, contradiction. But how to do this? So we have to solve here. So first inside the bracket I will solve. We know that P implies Q is nothing but negation P or Q. This whole thing is P implies R. Now again P implies Q. Negation of negation P or Q or R. If I do this negation, De Morgan's law, you have to write, okay, De Morgan's law like that. So double negation P and negation Q or R, double negation, this will go off. So my U is equals to this. So U the given was this. Now my U became this. So UD is equals to P or negation Q and R. Okay, this becomes R, this becomes and, same P negation Q R. Okay, I hope you understood this. They might give some other questions and they will ask you to like make. So see here, we had P implies Q, then that implies R. So we have P implies Q implies R. It won't be that different or something. And here also we have another type of thing. And here I'll, okay, you just see that, and now I'll explain that principle of duality thing. Okay, so the given is negation P and Q, which implies negation P or negation P or Q. Okay, so now what I will do, U is equals to, this whole thing is U now. Okay, so now see here, I have negation P or negation P or Q. So both are R. I can apply associate law and I can group it as P or negation P or Q. This will be equal to, so negation P or P is logical into P, right? So negation P or negation P is also equal to negation P itself and or Q. So this whole thing I reduce to this, implies negation P and Q. Okay, so now it is in the form of P implies Q, right? I will just how to say, open this. Okay, so P implies Q. P implies Q is nothing but negation P. Okay, this thing was P. Now negation P or Q. So double negation is there, it will become only P and Q or negation P or Q. Okay, so here we have this term now. Okay, so now further what we will do is, so here we will take this as what to say, De Morgan's distributive law type. So instead of making it short, here we will expand it further. Okay, so here this thing is in the form. So if I just group like this, so P and Q or negation P or Q, if I group it like this, so this is in the form of distributive law, P and Q are R. This whole thing is R, Okay, so now what I will do, P and Q or P and this negation P or Q. Okay, so I will do like this, P and negation P or Q, and then I will do P and Q. Okay, I can do it like this, or simply or another way we have like this, right? So this is or and this is and. If I have to multiply this with this, I can simply multiply this term with this term. I just multiply both. Okay, so this is and, right, and this is or. So I can write P and this term negation P or Q, or P, Q and negation P or Q. Okay, it's both are same, right? If I do like this, okay. Now if I have to take distributive law, what will become? So obviously it will become like that itself, P and Q, or this whole term will come, right? Correct only, right? So see here, it was I just separated this and wrote it in the form of distributive law. I hope you understand what I just did here. Okay, so P or Q and Q and R. Okay, or else better we can take this as P. So if I rewrite it, I am just explaining. Okay, I am not solving, I am just explaining you further step. So if I write P or Q like this, or okay, or P and Q, this is P, P or P and P or Q and R, like that it is in the form of like that, is that right? So now it is simple to write off. So I can write negation P or Q, okay, or P, and it's not visible, yeah, it's visible, and negation P or Q or Q. Same thing is here, right? So same thing. So see here, the distributive law is applied like this. So usually it will be like this, right? So what I just wrote, first I wrote this, from associative law we can shift like that, but directly we can apply distributive law from like this side. So this is P or P and Q, like that, P or Q and R, like that I took. So this I took as P, this has Q, and this has R. Okay, and then I just expanded it. So now see here, I have like this, and then I have like this. So here what I can do, I can negation P or Q is right, so I can write it as P, and I will open this negation P or Q, negation P or Q. If I just what to say, what is that law, associative law, I can apply and pair it like this. Okay, P and negation P or Q, then I can write or Q and Q. I will just pair Q and Q, or negation P, like that. So I will do it like this whole thing, or Q and Q, okay. So I can also write it like this if you want. So this thing was P or, yeah, as it is, we wrote, we came till here. This is one term, this is one term. So Q and Q is Q or negation P. Okay, then here I can write P and negation P. So this thing will become 0, so nothing but contradiction or Q. So here what I can do, again further, Q or negation P. So this thing will become Q again, Q, here R is there, or Q or negation P. Then again Q or Q is again Q. So again only Q or negation Q will be, negation P will be left. I can rewrite it again, U is equals to this. So UD is equals to, I can rewrite it, right, negation P or Q from associative law, and then I can write U is equals to this, then UD is equals to negation P and Q. which is equals to that's it. I hope you understood, right? I'll just show you in the book and tell you once. Okay, we did this like this here. So see, you just okay, now it's visible. You just see this and understand, try to understand, that's it. So we took this as one term, and if we can separate this also one, this also. We just solved this, and at the end we simplified it to one small term like this. We can also further negation P or Q can also be written as P implies Q, but we cannot take what to say duality on that. So we took like this and we completed. Okay, then we also have a concept here which is nothing but NAND and NOR. So we know which is and is this, right, and not is negation, or is this. Now I will take NAND. NAND is nothing but and plus not is equals to, or is not plus and. Okay, it is nothing but negation plus and. We can write it as up arrow mark. Okay, negation and this can be written as up arrow. Same way NOR, not plus or, not plus or, this can be written as down arrow mark. Okay, so we have here what is that? So they might ask what is NAND, what is OR. So now if we have P NAND Q, this we can write as not P and Q. Okay, because it is a combination of negation and, right. So negation P and Q. Okay, this both combination can be written as arrow mark. So P and P up arrow Q. Okay, so you can write like this. So it is, since it is negation P and Q, negation of P and Q, this can again further written as negation P or negation Q. Okay, so here we can simply write this is logically equivalent to P and Q. Again, this is logically equivalent to negation P or negation Q. Okay, understood, simple, right? Same way for NOR also, down arrow mark, you can simply write it like that. Instead of and or will come, that's it. Remaining everything is same. So they will say solve or simplify like this. So negation of P down arrow mark Q is logically equivalent to negation P or negation Q. We have to prove this. So we have to say, we have for any proposition P Q prove that like that. So we have to prove it. So P, this Q, right, this can be written as negation of P or Q. Then we have this whole negation. So this double negation will get cancelled. Only P or Q is left. Okay, and then this also we can solve it as negation P and negation Q whole negation. So this can be written as double negation P or double negation Q. So nothing but P or Q. So see here, logically equivalent, right? So simple. First this is one term, this is one term. We knew, right? Here I showed you here how it is equal. A very simple one. If you want me to explain it separately, properly, neatly, I can do that. I'll just take my book here, keep here and show you. Okay, so this one sum I will just solve. Okay, not all, because it's taking a lot of time. So now I have for any proposition P Q R, prove that P NAND Q NAND R is logically, okay, is it logically equivalent or not logically equivalent? I think it's not logically equivalent to P NAND Q NAND R. Okay, I guess it's not logically. We have to do it. So LHS we have to just find P NAND. So Q NAND R can be written as negation Q and R. Okay, now this is one term and this one term. So again negation P and negation Q and R. Okay, this will become one term. Okay, if I have to like further simplify it, I can write it as first P and negation Q or negation R, or better wait here, since it is in bracket, I will imply this negation first. So negation P or double negation cancel, only Q and R. Okay, so LHS I got negation P or Q and R. Let me solve the RHS part. So P NAND Q NAND R. So first I'll solve this negation P and Q. Then again I'll solve like this, negation of negation P and Q and R. Then I'll imply the double negation. So because of double negation P and Q, then here R negation R will come, because this is one term and this is one term. Since the double negation, it will get cancelled. So I got like this, P and Q or negation R. So here, so see here, we proved that it is not logically equivalent to this. Understood? Simple one, right? I hope further things are not necessary. Then they will ask you like further express this following terms in the form of NAND or NOR. Okay. So first thing is negation P. So negation P, I have to express it in somehow in the form of NAND form. So only P is there, so I can figure it out like I have to write it in the form of like this. So this can be written as P and P, right? So if I open this, so I can write it as P negation P or negation P. Okay, now see here, I have negation P. I know that negation P or negation P is again logical into P. See here, I wrote like this. Now just do backtracking. First I have this, then I will write P or negation P, then I will make it as P and P, then I can simply write it as P up arrow P. Simple, right? A very quite smart move like that. So now we will also see how we can write it as what is that, P nor P. For P nor P, it will be P negation P or P. Okay, this if I have, right, it will be P and negation P. So like this, again backtracking, you will get proper answer. For this is for NAND, this is for NOR. Okay, very simple, right? You understood. So similarly, now I will do for P and Q. Okay, so P and Q is there. So for P and Q, it should be P NAND Q. So this will be negation of P and Q. So if I do it like this, so if I have to further solve negation P or negation Q, so I only have P and what to say, P and Q, right? So if I take, I cannot change this. So here I can see what I can do. Here in the notes we are taking double negation of P and Q. Okay, it's like this and then like this. So first what we did, we took like this. So now what I will do, negation of, so now see here, negation, now it will become negation of P or negation Q. Okay, I got like this. Then what it will become, again I have negation outside, so it will be double negation of P and double negation of Q. Or else what I can do, I can simply multiply this with itself, so that I will get the same term. Here also I can just make it as a negation of P NAND Q, but again that will be a problem. So here I have negation of negation P or negation Q. So now what I can do, I will keep this negation whole thing outside as it is, and then I can simply write it as negation P or negation Q, and again same thing, because same thing into same thing is always same thing, right? Or negation Q. Okay, it's not compulsory that I have to represent it in this form. So I have here negation and here and, so I can simply write it like this, or else I can also write it as, so see this will become as negation P or negation Q NAND, again I have to write, so see here it's like this, but further simplified I can also write it like this. Okay, P NAND Q NAND P NAND Q, like that. Okay, you understood, right? Wait, I like just show here. Anyhow, it's not that much required that much. So see here. So this is nothing but negation P or negation Q. If I want to write this, it will be written as P and Q, right? Here also I can do. So simply what I can do, I can simply write it like here. It is there, right? Negation P and Q and negation P and Q. okay, whole thing has a negation. So I can just write it like this. Understood? Now this thing can be written as P9Q. This time we get it as P9Q, and this thing again we have whole 9, like understood. But if you simplify, it will be more easy and nice actually. Or directly you can write this here and simply write again this P9Q. I'll show again one more thing, and here you can simply write P9Q, negation P9Q. Okay, then this you can further write as P9Q and P9Q. I'm just showing you possible ways to do that. Okay, like this. Then same we have P or Q. You can do the same thing for this. Expand, take double negation, we'll get one thing, expand and then write. So now let me do for P implies Q. You know P implies Q, but negation P or Q. So I got P nor P, Q aram se. But what if I have to do NAND? Okay, I can simply try for going a double negation also here. P implies Q. So I know that double negation of P implies Q is what P and negation Q. Okay, and then I have one negation here. So it is and so here I can simply write what to say for implies also. For NAND, okay, double negation I have to take P and negation Q. So here I can directly write as same thing. This thing I can use. So P NAND negation Q. So for negation Q, right, is it right? So Q I can simply write as Q and Q. Q and negation Q, and simply again make it as okay, wait, I'll just write it here. P and negation Q is there, so I can simply open this negation Q. Okay, so what is this Q or Q? Remember negation Q and Q. Okay, negation Q and Q can be written as this. So it's not that much required, just leave it. So P NAND negation Q, you can just write it like this also. Okay, for what is that, P implies Q it is. Okay, for or you can directly you will get for what is it if you open this you will get P or Q, negation P or Q. So this is P and Q simple. For NAND you have to take double negation, you will get P and negation Q. So now what you can do for this negation, if you write P and negation Q, this negation Q, only negation Q. So we know that at the beginning we simply wrote negation P is logically equivalent to P NAND P, right? So same way negation Q I can write as Q NAND Q. Okay, understood. That's how they wrote here. Okay, this part is done. So now we will be moving for this converse, inverse and contrapositive and all. We have almost completed half of the module, I believe. So much topic is not left now. So we finished logical connectives, truth tables, tautology, contradiction, logical equivalence, loss of logic, duality. So only thing left is still a lot of things are left actually, like converse, inverse and contrapositive logic. So I guess 1, 2, 3, 4, some 3 to 4 topics are left. So I'll just tell you, suppose we have a statement P implies Q. Okay, so there are 3 things here, 1, 2 and 3. That is nothing but converse, inverse, contrapositive. Converse, inverse, then contrapositive. So this thing I can write it as, so converse of P implies Q is nothing but Q implies P, just ulta the letters. Then inverse, inverse means negation P implies negation Q. We are with not respect to this, with respect to this itself we are doing. Then contrapositive, then ulta of this. So negation Q implies negation P. Converse is nothing but this locations, like positions are being swapped. Inverse means the letters are getting inversed. So we know that in the beginning inverse law was right, P and negation P, P or negation P, is logically equivalent to like that. So this is always contradiction, this is always total like that. So that is inverse here, like that inverse. Right, converse is this, inverse is this, contrapositive is this. Sometimes we can just take directly a value like this to solve the further questions. So here let us see for a question. Sure, so I will use a book here because it is taking a lot of time. So we have write the converse, inverse and contrapositive of the following. If a real number x square, if a is real number, if a real number x square is greater than 0, then x is not equal to 0. So what they have said, if x is x square, if a real number x is a real number, then x square okay, wait, sorry, a real number. So first they gave us one proposition, x, a real number, what is happening, real number x square is greater than 0, then q, if p then q, then x is not equal to 0. So now if I write like this, p implies q, it is like this, right? So now what they have asked, they have asked, right, converse of this is q implies p, then inverse negation p implies negation q, then contrapositive negation q implies negation p. Do you stop here? No, you have to write this, and this in English. So q implies p. If x is not equal to 0, then x square is not equals to if a real number, okay, so you can write like this. So this can be written as, if a real number x is not equals to 0, then x square is not greater than 0. Okay, then how to write this inverse? If a real number x square is not greater than 0, then x is equal to 0. Why? Because here only normal x is not equal to 0. So like that. Then contrapositive, if a real number x is equal to 0, then x square is not greater than 0. I hope you understand this, right? Simple, very simple. Most of that is nothing is there. So yeah, if Kabir wear brown pant, then he will wear white shirt. Okay, it is like this. It is in the form of p implies q, where p is this, q is this. So converse, inverse, contrapositive you write. So if Kabir wear white shirt, then he will wear brown pant. Okay, first what was there, brown pant and white shirt. So if you have white shirt, brown pant, so it is that's not converse. Inverse, just see here. Okay, I'll just show here. If you read, you should be able to understand this. If not, I will just bring it closer to the camera so that you can see it, take screenshot or whatever, because I don't want to waste much time here. Okay, so here they have written, write down the contrapositive of p implies q implies r with two things, only one occurrence of the connective symbol. Okay, so this is very interesting sum. So they have given p implies q implies r. What they have done, we have to simplify this and find the contrapositive such that only one this implies symbol is there. Second, no implies symbol is there. The symbol should not be there. So very simple. So first thing, only one symbol should be there. So I can simply open this. Okay, so p implies q, or simply I can write p implies negation q or r. Okay, so this is my one term. So I have to find the contrapositive. How will the contrapositive? So this is in the form of p implies q, right? P implies q. Then I have to just reverse it. Negation of negation q or r implies negation p. Then this can be written as negation q and negation r, not negation, only q and negation r implies negation p. Okay, so this is our one term we got here. Okay, or directly you could have taken in other way, like simply open this also. So negation p or q implies r, or else you can have like this also. See, negation p or q implies r. You could have done this also, right? So this is our one thing. We got one. Okay, and then another thing what it said, we have to further simplify in such a way that there shouldn't be. Okay, first we have to take the contrapositive of this. Sorry, one thing I missed here. P implies q, right? Then which implies r. So what's the contrapositive of this? So if I have to take contrapositive, it's nothing but negation q implies r implies negation p. Now I have to solve it in such a way that only one this symbol left and no symbol left. So first thing, only one symbol. So I will just open this negation of, so double negation will come, q implies r or negation p. So since double negation, so I just open p implies q, negation p or q. So double negation, this will get over. Further thing again, just simplify this step again. Okay, so q implies r is right. So negation q or r or negation p. So this was they asked for first thing, this was they asked for second thing. Okay, so now we'll be having this logical implication and all, where they'll give LHS and RHS and all. So here few things will be there which you have to solve here. It's not that different from any other thing. It's very simple. It's a logical implication. Actually, we have already solved this in the beginning. I'll just show some examples for you. What they say, logical implication, they'll give an okay, so see here, I'll take one example. P and P implies Q. Okay, this whole thing they have said it is logically equivalent to Q. So what you can do here is that either you make truth table. Usually you should make truth table. They didn't say without truth table, directly you have to know, right. So I'll just show here one thing. So P and with insertion. So I was explaining that P and P implies Q is logically equivalent to Q. So I'll just take an example of 3 questions here to explain this in a very simple manner. 1, 2 and 3. 3 questions. So here this is one question. Another question is P implies Q and negation Q. Okay, which is logically equivalent to negation P. And another question is P or Q and negation P, which is logically equivalent to Q. So here basically what I have to do, only P and Q. So first let me just write make a truth table 0 0 0 1 1 0 1 1. Okay, now whatever is there inside I have to make it 1. So I have negation Q also, negation P also. I'll take negation P, negation Q. So it is 1 1 0 0 1 0 1 1. Then I'll take P implies Q. P implies Q is in fact 1 1 0 1. How is that? Just see in the beginning of the video, it's there. And then what I have, so I have, okay, then I have P or Q. That's it, P or Q. Okay, P or Q. What is P or Q? 0 1 1 1. That's it, right? Now see here, to prove this, what I have to say, when this and this is true, this should also be true. If there is only one condition, okay, which satisfies that, then it's true. So see here, P here and here it is 1, and P implies Q, it is 1 in that place. So when, and also at the same place, so here you can see when P and P implies Q is true, then Q is also true. Okay, I'll just highlight it with another marker. Just a second, where is it? Where did I keep the red marker? Okay, it's lost. Like usually when you need something the most, even if it is in front of your eyes, so you cannot find it. Okay, so no problem. So here, then second thing, so I have to find that when P implies Q and negation Q is true, then negation P is also true. So see here, P implies Q is true, and negation Q is true, and also negation P is true. So this value, so from the table you can write from the table, when both P implies Q and negation Q is true, then we have negation P is true. So Q is should be 1. So P or Q should be true and negation P should be true, then it logically equivalent to Q. So Q is 1 here. So P or Q is 1 and negation P should be 1. So see, P or Q is 1, negation P is 1 and Q is 1. Okay, you understood, right? So this was very simple and easy. So same way you can just find so many answers for so many problems. So this completes our this what to say logical implication problem. So now we will be moving towards rules of inference. So we have basically some 5 to 6, 7 rules of inference. Okay, So in this thing you will be having to again like how we had laws of logic, 10 laws of logic. In this you have to find rules of inference. So there are basically 7, and you have to find the answers for that. Okay, so using that 7 rules of inference, you will be finding further. I think this is the last topic, and further much more is not required for us. So if I just check the syllabus copy, so rules of inference, then if we say mathematical logic, so we have open statements, quantifiers, logical implication involving quantifiers, statement with more than one variable, and methods of proof and methods of disproof. So quantifiers is one of the easiest topic. If I just finish these rules of inference, then only quantifiers is left. Okay, so let me just start. So first rule of inference. Okay, rule of inference, P or Q is logic, it implies logical inference. Okay, so P or Q is logically equivalent to P. Similarly, Q and it's not, I'm saying or, Q and P is logically equivalent to Q. Okay, so this is one of our what to say rule. First rule of should I show in textbook? It's more easy, right? I hope you can see it. Okay, so see a rule of conjunctive simplification, which says that the rule states that for any two propositions P and Q, if P and Q is true, then P is true. So the same way we did in logical implication. If P is true and this is true, okay, both should be true, then this is also true. Okay, the rule follows from the definition of conjunction. Now, second one we have, I'll just move this, rule of disjunctive amplification. So this rule states that for any two propositions P and Q, if P is true, then P or Q is also true. That is, so since it is so here if P is true, so P or Q will always be true. Why? Because we already have P as true, right? So P will be 1. So 1 or 1 or 0 will always be 1. So P implies P or Q is always true. Simple thing. Then rule of syllogism. The rule states that for any three proposition P, Q, R, if P implies Q is true, then Q and Q implies R is true, then P implies R is also true. That is, if P implies Q is true. Okay, if I just explain that, P implies Q is true, 1, and so this and Q implies R is also true. Okay, then P implies R will also be true. Okay, if we have to take one example, so suppose, okay, I'll take this 1, oh no, I can't take 1, 0 to 1, this is true. Then again if I take this, so since Q is 1, 1, this should also be true, right? 1 to 1 is also true. So again 0 to 1 will again be true. Understood? That's what it says. Then one of our most important rules of inference, modus ponens. So in modus ponens there is a rule of detachment. So we have the rule states that if P is true, then P implies Q is true, then Q is true. Okay, P is true and P implies Q is true, then we will have only Q that is true. Okay, suppose 1, then 1 to 1. Okay, if P is true, then when will P implies Q be true? 1 implies 1 will only be true. If 1 implies 0 is false, so this cannot be 0, right? Then therefore Q is also 1. Understood, right? Basic, they are giving one condition. If P is true and P implies Q is true, if P is true, P is equals to 1, then prove find value of Q, they will say in beginning, starting of the questions. How will you find? Since P is 1, so I told you, right, you have to find a truth table. So P will be 1, 1, and this Q will be 0 or 1. Okay, further to 2 values, right? If I take P implies Q, so this will be 0. Why? Because decreasing, this is equal, so this should also be 1. So what it says, if P is true and P implies Q is true, then obviously Q is also true. Then I have modus tollens, which says that the rules are if P implies Q is true and Q is false. Okay, so first we will take P implies Q as true and Q is false. Okay, then P is also false, negation P. So what it says, if P implies Q is true but Q is 0. So here we know that P is 0, so here it can either be 0, only 0 itself, it cannot be 1. If I take 1 plus 0, so this is not true, right? So P implies Q should be what to say, true. Okay, it's not visible. Yeah, P implies Q should be true. So and they said Q is false. If Q is false, so obviously here it should be 0. So if P is 0, then then P is false. So instead of writing false, we are writing negation Q, and instead of Q is false, we are writing negation Q. Instead of writing P is false, we are writing negation P. Okay. So this was modus tollens. Okay, usually how they denote all these things is nothing but instead of writing like this, they write like a mathematical addition. For example, for rule of syllogism, they wrote P implies Q is true, Q implies R. What is the value we get? P implies R. Okay, then let us same way. You can see here, you can see here. Now going for other rule of disjunctive syllogism. The rule states of P or Q is true and P is false, then Q is true. Okay, so P or Q is true and P is false. So obviously Q is true. How this thing comes is, what they say, P or Q is true. Okay, this is true. This gives us true value, and P is 0. Okay, 0 or what terms gives us 1. So obviously 0 or 1 gives us 1. So from this, what we can say, Q is true, right? So similar. So what? How we can write this? P or Q and negation P gives us Q. I am just giving a proper way to understand this. Then last one, last rule. The rule states that if negation P implies F naught is true, then P is true. Okay. Now see here, negation P implies F naught is true, then P is true. So here see, F naught is always 0. We know that. So what implies, so 1 to 0, okay, cannot be possible here, since you are taking negation value here. So when this will be true only if it is 0 here. If negation P is 0, then obviously P will be 1. Okay, that's what it says. So they have taken one truth table also here just to explain that. So let us take one example. Okay, there are many examples for this. Instead of using the book, I will just explain here. Okay, I don't want to waste so much time. So they said test whether the following is a valid argument. Okay, so this comes under rules of inference. So if Sachin hits a century, then he gets a free car. Then another one, Sachin hits a century. So here, if P, then Q. Okay, Sachin hits a century, then Sachin gets a new car. So here P, Q, and again we have Q here. So this can be written as P implies Q, in the bottom P. Okay, let me just show here. So what they have said, if Sachin hits a century, so that is P1, proposition P, where Sachin hits century, Q, Sachin gets a new car. Okay, so now how it is, if Sachin gets a new car, so P implies Q and Q. Okay, so this should be logically equivalent to, okay, so and P, not P, this should be logically equivalent to Q. Okay, see here how it from we have these rules of inference, right? So now see here, is it equivalent to some other any rules of like that? You have to see. Main thing is this won't be given in any what is that, handbook and all. You have to learn and understand by heart this. So see here, modus pons. Okay, P implies Q and P will give us Q. From modus pons also we already have. It's nothing but it's in the form of like this. P implies Q is also equal to Q. Therefore, from modus pons we can directly say that this thing is a valid argument. Okay. Same way, I don't think now I have to further write and explain. Now you can see here, test whether the following is a valid argument. If Sachin hits a century, he gets a free car. Sachin does not get a free car. Then we have to what to say? Therefore, Sachin has not hit a century. So we have to prove that it is a valid argument or not. Okay, so see here, P is this, Q is this, and this is negation Q. Okay, so same thing, first thing we have P implies Q. If Sachin has a century, he gets a free car. Then they say Sachin does not get a free car, negation Q. So this should be equal to negation P. What? Sachin has not hit a century. So let's find. So P implies Q, negation Q. Okay. So in the view of modus tollens, so instead of pones they are using modus tollens. So see here, modus tollens same to same is appearing, right? You can see here. So modus tollens like this, and here also is the same. So like that. The same way, I'll just show you the textbook here, one by one. Just take the snapshot of it, and then understand. So we have further so many examples here, like example 4, then example 5, then example 6. Is it not clear? Sorry for that if it is not clear. Okay, now is it clear, right? You can simply take screenshot like this of the whole textbook itself. I mean 4 pages. So they will give 3, 3, 3. Once you just practice this in the examination, this will be helpful for you. Example 10, example 11, example 9. You just first, if you want, I can keep rules. Take screenshot of this, write it, better write it down, then only you understand. If you don't write it, then it's a waste whatever you are studying. So problem 9, 10, 11, screenshot 12, 13, 14. You can see the problem, right? If you want me to explain first any one of the problems, just comment down. I will explain that particular problem as a short reel, okay, within a minute properly, so that you will understand it. Okay. So there are so many problems in this. Refer the model papers, you will understand how these people are giving. Few are very easy. So from here, okay, actually from here, from this part, from example 19, things are very easy and simple. This is a very easy one. This will be pakka one will come from this. I can guarantee that. Why? Because it's very simple and easy. So last we will move on to this open statements and quantifiers. Okay, so quantifiers, these things is very simple. I will just explain you here. So there are two quantifiers, universal and existential. Okay, oh, it's like this, I guess. Okay, universal means the condition is true for all the statement is true for all the conditions, always true. Okay, it satisfies all the conditions. There exists among the given set of conditions, only one or two is true. The most important question is asked. So they have asked here. So see here what they say. For the universe of all integers, so for all x, okay, they say p of x is greater than 0. So they are giving propositions. So the p of x is this, q is this, r is this, s is this. So now what they saying, at least one integer. So they are asking us. So see, I will explain this thing here. So for all x, we have to prove this. So first thing they have asked, at least one integer is even. At least one integer is even. So there, so where we know that q of x is even. So there exists x such that q of x. So this will make us at least one integer is even. Then there exists a positive integer that is even. So it should be positive and it should be even. So here they have not mentioned anything as positive, but we know that x greater than 0 is positive. So there exists x such that p of x and q of x. Okay. So simple. I am not seeing here. Okay, don't think I am seeing here. I will just hide like this. Then some even integers are divisible by 3. So sum is nothing but there exist. So see, even integers means p of x, etc. Then divisible by 3, x is divisible by 3. So there exists x such that some even integers is divisible by 3, p of x and f of x. Then every integer is either even or odd. Every integer means for all x. So either even and or odd. Where is odd? It's not given. So what we'll do, q of x and negation q of x. How we take this? Simple. Why? Because q of x is even. If q of x is not even, then obviously it is odd, right? So negation q of x. Then last another, if x is even and a perfect square, then x is not divisible by 3. Okay. So if x is even, okay, it's like what to say, x is even, so q of x and okay, and is there, and a perfect square number, and r of x, oh what am I doing, okay, and r of x. So what is if x is even, and then implies, this whole thing implies the x is not divisible by 3. So negation s of x. Okay, it's very simple. So they have said they have not said sum. So if they are saying in open statement, right, if x is even and perfect square, then it is not divisible by 3. So it should be satisfying for all x. Okay. Similarly, if x is odd or x is not, see, if x is odd means negation q of x, and not divisible by 7, negation t of x, then x is divisible by 3, which implies s of x. This also will be for all x. Okay, very simple question, right? Over, done. So here, see here, only one question was there. Another question will be there for his example, where they will give the values of each thing. P of x is equals to, so they will give an equation, and p of x is x square plus 1, x is greater than 0, like that. Then they will ask you to prove. If you have any particular question, you can just let me know here. So even further questions also will be given. So here, example 3 considers the open statements p of x, q of x, r of x, s of x, of example 2 itself, same to same. Express each of the following symbolic statements in words and indicate its truth value. So for all x, r of x implies p of x. So here you see here, if I keep like this, okay, straight, okay, it will be easy. So you can see here these values. So you can say that r of x is nothing but x is a perfect square number, and p of x is greater than 0. If r of x is perfect square number, then x is greater than 0. For any integer x, if x is a perfect square, then x is greater than 0. So this is false. If we have, okay, since it is for all x, right? Now see here, for all x, if r of x implies p of x, this is x greater than 0, and this is x is perfect square number. Okay, this is not less than equal. So 0 is also a perfect square number. Why? Because perfect square number. Why? Because it can be what is that? Perfect square, like 4 2 2s are like 2 square, 3 square, 4 square, all are one perfect square number. So we can take simply 0 should also. So 0 is not greater than 0. So perfect square, if I take minus 2 also we can take, it gives us 4, right? Then here it is minus 4 is less than like that. So take 0. So it should satisfy all the conditions. If you take here one value is minus, but it is not greater than 0, like that, then we have there exists x, s of x, and negation q of x. Mostly whenever they say there exists, right, it will always be true, because any one thing is satisfying, it will satisfy. Let us see this here, s of x and negation q of x. For some integer x, x is divisible by 3 and x is not even. Okay, in other words, so what they are saying, x is divisible by 3. So there is a number 9. Suppose if you take 9 a number, if you divide 9 is divisible by 3, but 9 is also not even. So there exists. So 9 itself, 9 can be divisible by 3, but 9 is not even. So 9 is odd. So this true. So this for all x, negation r of x. For all x, x is not a perfect square number. In other words, no integer is perfect square number. This is false. If you take 4, if you take 9, it is a perfect square number. So it's false. Okay, and now see here, last statement, for all x, r of x or t of x. For any integer x, x is a perfect square number or x is divisible by 7. This is false. Okay. Take x equals to 8. Okay, 8 is not a perfect square number, and it is also not divisible by 7. So both things are false here. 0 or 0 is 0, right? So it is false. Like that they will ask. You just see the problem. So this completes the first module. Thankfully, hopefully, if I have missed anything, it will be probably some easy part, you can just read and understand. I am just showing all the examples, see here and do it by yourself. I don't think I have to explain so much in this. I'll just take a break, nice break, and then I'll be explaining the other modules too before the exam, obviously. Logical implication involving quantifiers, these all are like few extra type of things. You can see this also, this will also come, okay, for this is also important one part. I might explain this as a short reel, 1 minute reel or something like that, or a short video. You can see all one by one, just pause it and take screenshot, whatever, done. Okay, so it's this completes the first module. Okay, long man, almost took 2 hours or some change, I guess. And please, not just simply watch and leave, man. Subscribe and like also, right? What will happen? You are simply just selfish people and all. Shame on you guys.